Alright, well, welcome back. This is part 2 of the last video. We start to discuss few notation regarding probability and the value of probability in regard to how we define this class here. Now we discuss there's different approaches to calculating probability. So consider the following examples. Suppose we toss a coin. Assuming that is a fair coin, to find the probability that it will land on heads, and everyone knows there's two sides, heads or tails. So if you toss a single coin, the chance or the probability that the coin will land on heads, is 1 out of 2 because there's two possibilities. So there's either heads or tails for one single coin toss, so that's sample space. So there's only one head, so you get 1/2. How do we know this here? Because there's only two outcomes, and we know that the coin we toss, we assume that is a fair coin. This is most of us assuming here, but if we were to toss in a styrofoam cup or a coffee cup here, what will be the chance or the probability that it will land on its top? Okay, so the probability of the cup here land on its top. Okay, so let's look at the sample space here. So for a styrofoam, of coffee cup, we can have top, right, or side, or bottom. Sure, okay, that's another outcome. Top, side, or bottom. That would be the sample space. The problem with this is with styrofoam cup, these three different outcomes don't have equal chance of happening. Whereas the heads and tails we know is a fair coin, so either we get 50% chance getting heads or tails every single toss. With the styrofoam cup, we don't know that. Oh, actually, we do know that they have different weight to the different size of the cup. So when you toss it, we don't know it's gonna be a third time it's gonna land on the top or the side or bottom. So we don't know that. So in this case here, we're gonna roughly estimate it. Maybe 2/3 times, maybe a third time. We don't know. We don't really know. So with this here, we have the outcomes. We call that scenario. So we say that in this case here, we don't know because the outcomes has side or bottoms are not equally likely. So in order to get this answer here, we need to conduct experiments, or we need to do a lot of trials. Meaning, if we were to flip the cup 100 times and record how many times the cup lands on its top, then we can say the probability of the cup landing on its top will be approximately this many times out of 100. So certainly we can see that, we think that it's always the same way of calculating probability, but that's not true. It depends on the sample space, depends on the outcomes being equal likely happening or not. In this case here, the outcomes are equally likely, meaning they have equal chance happening. All right. So that brings us to the three different approaches here we're going to talk in a minute. Let's look at this example. A bowl containing 5 black marbles and 1 red marble. So we know there's 6 total. Without looking at the bowl and randomly picking one marble out, where is the probability that a red marble is getting picked? Okay, so imagine a bowl containing six black and 1 red. We're not looking at as we're picking one marble out. Okay, so we want to figure out what's the probability that a marble getting picked is a red marble. So a red is getting picked, getting choose or picked. Okay, well, we know there are 6 total marble, right? And there's only 1 red in there. Okay, So since we are randomly chosen that without looking at it, so there's no bias, so it's just random, right? The chance of us picking a marble that is red out of 6, well, there's only one, so we say 1 out of 6. So in this case here, we know the exact probability because all 6 different marbles are equally likely getting picked because we're doing randomly, right? As opposed over here where the outcomes are not equally likely being picked or being happen. Here's another way of calculating probability as well. If a year is selected random, find the probability that a Thanksgiving Day in the United States will land on a Wednesday. Well, if we live in United States, you know that Thanksgiving is always on Thursday. Okay, so for any random year we picked, the probability of Thanksgiving being on a Wednesday, Thanksgiving on Wednesday, that probability is 0. It never happened. Where over here is, Thursdays, it's gonna be 1, right? So this is more like a subjective. And then this is more like a classical approach. Okay. All right. So and then this one here, this is more of like relative frequency approach here. Okay. So let's discuss these 3 different methods briefly. 3 different ways. The first one is relative frequency or empirical. This is more like trials to experience. Okay. This is where we use trials to approximate the probability of some event occur by conducting the number of the procedure and see how many times an event occurred during that procedure, right? So notice that we have approximation symbol right there. Okay. An example of this would be car crash, right? When you look at the rate of car crash every year or certain model, that is based on the number of trials, number of car accident happened. It's not based on relative frequency or not based on, certain equal chance of happening. Like different car has different crash rate because just based on their technology built or just how safe it was being built. Or another example would be weather, right? What chance of being rain on a certain day and things like that. So these are relative frequency, or even just the infection rate of COVID. And that's on relative frequency. Oh, let's go back here. Oh, there is a glitch. Go back. No, that's not it. All right, so let's go back to this one. Infection rate of COVID, right? So that's based on relative frequency. They look at the population, look at within that population how many people has been infected, and then look at the daily rate and monthly rate, and then you kind of do a certain trial and see how many people can be infected from a large group, and then from there you approximate the number, and then hopefully from that you can just estimate as accurate as you can. But then it also depends on the lurking variables. It depends on different area as well. So there's a lot going on there, but you can see this would be some example that has to deal with relative frequency, a different way, a more realistic way to approximate probability. The second one would be classical. This is called classical approach or theoretical approaches. This is more of math required. This is when we know that in a procedure, every single simple event has an equal chance of happening, just like the marble example. And in order for us to calculate the probability of certain event A to occur, then we just count how many times A can occur. And this, we can calculate the exact probability, whereas this is just approximate. Okay. An example, this would be guessing true false quiz or exam. Right? If a quiz contains 5 questions and each question has true or false, right? When you guess the correct choice on this here, each of those outcome has equal chance of happening, right? Right. Or that the other example we used earlier already is given birth, or picking a card from a deck, 52 cards. Lastly, subjective probabilities would be the way we calculate probability based on our personal experience or just educated guess or things happen in our past, and we just use that to make a decision or guess what would happen. This is more like tied to an example like, let's see here, what would be the probability that you get stuck on the next elevator that you ride? Right, so that's just based on personal experience. If you happen to get stuck quite often in the elevator, you know that you're gonna guess your chance gonna be high, but elevator now is pretty safe. Whereas someone that have never got stuck in an elevator, they might say, okay, my chance of getting stuck in the next elevator I ride would be probably like 1%, right? Not even close. So that's just subjective, right? Everyone has different personal experience to make it a guess or a prediction on what the probability would be. Um, I'm gonna go ahead and pause in this video, and then the next video I'm gonna do a several example on this notes here.